So I'm going to be talking about natural language SQL. And what that means is I want to be able to write a question and it's going to go into my personal SQL database with a bunch of information that no one else but me knows. And it's going to give me an answer, right? So what's the goal and what's the purpose? Well, the goal is pretty simple, right? I give you regular text, I get back information. But the purpose here is that it just opens up a lot of different possibilities. I mean, think about the use case for businesses with all their private data. Think about the use case for just apps for different kinds of enthusiasts, for different products who can just ask for some information and just get it. And if you're a professional, right, you might have some really gnarly databases out there that you're working with, and you might just not want to go through the process of figuring it all out. It might just be an easy tool to, get some instant information out there on a first rough cut. So with that starting point, I asked myself, what am I going to do this on? What do I know? Well, what I know is basketball. So we're going to go with basketball data. And we're going to use two different databases because we're going to look at two different problems. One of the databases is built properly and is nice and consolidated. The other database is not. So the main sort of questions we're going to answer here is, can the system understand the table's underlying structure or the database underlying structure? And can the system understand basketball jargon? The first case, we'll be looking at a nice consolidated database. Now, this database, it has all kinds of things like, player averages, that's a table. It's got an entire table of every player's game logs all together in one table. It has one table that's rosters, that's the roster table, and has every team and every roster all in one table, all nice and neat. So we can go ahead and ask it some relatively simple questions like, on average, who scores the most points, or who scores the most points per game? These sound like the same question, but as we'll see, you might not get the same answer. And then we can toss in some basketball jargon like who averages the most triple doubles. And then we can get a little bit more fancy and say, hey, give me a really big thing using a lot of different basketball jargon, and here's some formatting you want, right? So let's hop into that. And let's look at the results. I have these pre-done already because they could take anywhere from like 10 to a lot of seconds to do. And since I actually know the answers, it's fine. Who scores the most, on average, who scores the most points? Joel Embiid scores the most points on average with 33.1 points per game. That is correct. Great. Question 2, who scores the most points per game? This is not the right answer. Damian Lillard does not score the most points per game, and on average, he does not score 0.5 points per game. Why did this happen? Because the way LangChain works, which is what I'm using, is it tries to understand the table, and it said, who scores the most points per game? Well, there's a table about averages, so it pops into that table, and then it sees there's a column about points. Now, it can't understand that because you're in the table called averages, that it's looking at a point average. All it sees is points. So it's going to take this points, which is already an average, divide it by the number of games played, get some number that's absolutely meaningless, and it's just going to be totally wrong. Prompting matters, as we will find out. So let's try to go to a different question. Who plays for the Lakers? Wow, this is true. I'm a big Lakers fan, got them all right. Went into the rosters database, got everything correct, every single name. Who averages the most triple doubles? It has no idea, because when it looked into the table, player per game statistics, it has no idea what a triple double is. Not a clue. I know what a triple double is. Many of you might know what a triple double is, but the system has no context for that term. But if you give it different terms, like this one, give me the top 5 players with the most games with 25 plus points, 5 plus assists, 5 plus rebounds. Each player had, and return the answer as a numbered list 1 through 5 in this format, player name and number. It understands every single one of these little things. It understands that ribas is rebounds, and it gives me a nice numbered list telling me exactly how much of these types of specific games every player has had. It's very wishy-washy on this. Sometimes it'll get it, sometimes it won't. And as a matter of fact, sometimes it can give you a lot if you ask of it, and it'll be correct. In this case, I asked for 30 players, and it gave me 30. So that's how it works in a cleaner database, in cleaner contexts. What happens if we try to get a little fancier with it? And we say, hey, what if you have a really large disorganized database? You run into a lot of problems. So this particular database, imagine instead of having one table with the game logs for every player and say like, okay, this player is, LeBron James, here's all his games, and here's Steph Curry, here's all his games. You have a LeBron James game log table, a Steph Curry game log table, a Giannis Antetokounmpo game log table, just tons of tables all over the place, super disorganized, made improperly, or just too many tables in general. What are you going to do? Well, this is hard, right? I made a kind of solution to this, but we'll see how it runs into problems. And what I did was I created an interface where you can say like, okay, not only can you give me a query, and by the way, we'll talk about why you can't have 500 tables in a second, but I'll say, hey, here's a query. And you know what, since I'm familiar with this data, I can even tell you which tables to hop into. So in this case, I say, hey, look at this DeMar DeRozan table and look at this Malcolm Brogdon table. And we have one difficult question, which is compare Malcolm Brogdon and DeMar DeRozan, very open-ended, very vague. And then we have kind of a more simpler question. Who has 15 plus point games? Who has more of them, DeMar or Malcolm? So we go back and we take a look and we see you put in the query just as it is. And you see, oh, wow, DeMar DeRozan, he scores more points and has more assists than Malcolm Brogdon, is getting the right numbers. And then it returns you, however, Brogdon has slightly higher average in rebounds, 4.18 compared to DeRozan. Now, I'm not quite the math whiz, but I'm pretty sure 4.18 is less than 4.64. So half points for that one. It was kind of there, but also kind of not. If you try to ask it the quote unquote simple question I gave you, it gets an error. This happens a lot, especially in this kind of framework where you give it limited information, because it's just going to go in, try stuff, have errors in the SQL, have errors in the tokens, all kinds of problems. This right here is kind of the holy grail that I've been trying to crack over the last week and have been unable to up to about 47 minutes ago. So that begs the question, where are we at and what can we do? In terms of the design challenges, naming is really important. Naming of tables, naming of columns. That's how the system interfaces with the data. That's how it understands the data. And when you send, I'm using OpenAI, when you send this up to be understood, a lot of times you're also passing as part of your sort of token input the first 2 to 3 rows of your table to get more context, right? So that matters. The right prompts also make a big difference. Better prompts means more accurate results. And as a matter of fact, there's a lot of good prompt templates that you can put in the code that'll add a lot of power to your prompts. I tried it. I found success in some cases, not quite as much success in other cases, but there's a lot of good stuff there. I doubled down on that one. Well, you know what? It's doubly important. And providing more context to the system is really important also. And that could come into play as like fine-tuning it for your specific data. Now, that's a really hard one. There's a lot of different ways to potentially tackle that one. I don't know quite yet. As for the technical challenges, SQL queries sometimes just don't work. Big issue, but you got to kind of work around that. And the token limits are the biggest issue by far. If you have a lot of tables, it needs to examine all the tables, which means it needs to examine all the names of the tables, all the columns of the tables, which means if the token limit for OpenAI is like 4,000, guess what? It's just going to send you an error and say, you can't do this. So if you have too many tables, too much table info, queries all set are too long, it's just not going to work. So like I said, the holy grail is, how do you expose only the tables that are necessary? That's it.